Greetings of the day. Let me introduce myself. My name is K. Mahammad, working as Assistant Professor in the Department of Computer Science and Engineering, Artificial Intelligence, Madanapalli Institute of Technology and Science, Madanapalli. First of all, I am thanking the management and my department HOD to provide me this opportunity to present some lecture related to this video series. And today, I am going to give a video lecture on Introduction to Data Structures. This is the flow of presentation: introduction, classification of data structures, data structure operations, representation of data structures, arrays, and linked list. The difference we are going to see it, and a graphical representation of data structures. And for this material, whatever the references I used, that references I added at the end of this slide presentation. Now we will move to the first topic. Coming to the introduction related to data structure, before going to the necessity of the data structure, first we need to know what is a variable actually. So variable is a name given to memory location. We know that the definition of a variable. With the help of variable, we can store a single value. Now consider a situation in a college, some students are there, some 1,000 students are there. Now what I want to do is I want to store this 1,000 student information. Okay, so student generally consists of some attributes like a student name, a roll number, gender, marks obtained in each subject, address, mobile number. These are all the data related to the student. If I want to store this information in a database, what I have to do is with the help of a single variable, I cannot handle this huge amount of related data. So what is the drawback of this variable means? Here, if you consider this case of example, here student consists of so much of related data. So with the help of single variable, we cannot handle this huge amount of data. Okay, so to overcome this problem, what we use means we use a data structure concept. So because of that reason only, data structure concept, it was introduced. So with the help of data structure, what we can do means we can handle huge amount of data. Now coming to the definition of a data structure is a way of organizing or arranging the data in computer's memory so that it can be used or accessed efficiently. Now we'll go to the next slide. That is a classification of data structures. Coming to the classification, so data structures are classified into two broad categories. One is a primitive data structure. Next one is non-primitive data structure. Coming to primitive data structure, so these are called as a basic data structures. They directly operate on the machine instructions. So primitive data structure directly operate on the machine instructions, and they are having different representations in different computers. Examples of this category like integers, floating point number, character constant, string constant, pointers. This and all fall under the category of primitive data structure category. Coming to non-primitive data structure, they are sophisticated data structures, and actually they are derived from the primitive data structure. And they mainly emphasize on the structuring of homogeneous data items and heterogeneous data items. So if you consider some examples related to non-primitive data structure, list, stack, queue, tree, graphs these are all the non-primitive data structures. Now, in the next slide, we are going to see a detailed classification related to all the data structures. If you look into this particular slide, here we given the classification related to the data structure like a primitive data structure and non-primitive data structures, that category. Under primitive, we mentioned integers, character, float, and pointer. So these are all basic data structures actually. So that directly operate on the machine instructions, and they are having different representation on different computers. That's why they are called primitive data structures. Now coming to non-primitive category, again, there are two categories are there. One is list category, another one is array category. So this array category also we can call it as a linear data structure. List is also called as non-linear data structure. Under arrays, again classification, if you see there, a single dimensional array is there, two-dimensional array is there, multi-dimensional arrays also there. Under list, linear list and non-linear list also there. Under list category, linear list and non-linear list is also there. Under linear category, stacks, queues, and linked lists. These are all some examples related to linear data structure category. Under non-linear, trees and graphs fall under the category of non-linear data structures. So here, if you look into the terminologies, so actually data structure classified into two categories, like a primitive data structure and non-primitive category. So primitive, non-primitive is a one kind of terminology. And next, another kind of terminology is like linear and non-linear category is there. So already we know about primitive, non-primitive, and coming to linear and non-linear. So linear data structure is nothing but the data in this linear data structure, the data is organized in the linear fashion or sequential fashion. That's why these are called as linear data structures. So if you take a stack, a queue, linked list, so they are how they are going to organize the data items means in the linear fashion. Okay. Now coming to non-linear category, in non-linear data structure, the data is organized in hierarchical fashion. Okay, level by level, if any data is organized means then it is called as a non-linear data structure. Trees and graphs fall under the category of non-linear data structure. Now here the important point is if you take a linked list actually fall under the category of linear category. Okay, but these items are arranged in non-sequential fashion. Okay, so this point all of you make it remember. Okay, linked list fall under the category of linear, but actually these items are connected in non-linear fashion. Now this is the classification related to the data structures, different data structures. Now coming to the data structure operations. Now here I listed some basic data structure operations. Now these operations are commonly we can perform on any type of data structure. So earlier classification, if you recollect in the previous slide, there I mentioned a list of linear and non-linear data structures category. Okay, so these operations, whatever we are here showing, these are operations are we can apply it on any kind of data structure. So we will see one after the other what is the actually purpose of all these operations. So first one is a create operation, next one is insertion, next one is a deletion, next is traversal, next is updating, next one is searching, next is sorting, merging, destroying, and deletion. Now if you see here, all these are the list of operations that we can commonly apply it on any kind of data structure. Now first we will see what is meant by create operation. See, before you are using any kind of data structure, first what we have to do is we have to create a data structure with some memory, some size. We have to specify and we have to create the data structure. How we can create means with the help of this create operation only we can create it. Okay, suppose I want to use a stack data structure. Then I have to specify a stack with some size. How I can do it means with the help of this create operation only I can do it. Now, moving to the next operation, insertion operation is there. Insertion is nothing but inserting an element into the data structure. So after completing the first operation, that means after creating any data structure, next operation is you want to insert some element into data structure. How you can do that operation means with the help of insertion operation you can do it. So if you consider an example like suppose I created a stack with size 5. Okay, so then next step I want to add elements into the stack. So how I can add elements into the stack means with the help of this insert operation only I can add the elements. So single time I am going to use one insertion operation and I add one element into the stack. If you look into the stack, generally we use a terminology called push terminology in order to insert an element into stack. Okay, so based on the data structure, this particular insertion operation terminology also, that terminology wise the word we are going to use a different words. So this is a generalized terminology whatever I mentioned here. If you take into any data structure like stack and queue, there for insertion we go with some different terminologies, some names are different only, but it will perform same kind of operation. If you take a stack means in a stack we perform insertion, that means inserting an element into stack, it will be performed with the help of push terminology. If you take a queue data structure, how insertion will be performed means with the help of enqueue operation. So terminologies are different, but what it will do means it will perform same kind of operation, insertion operation. Now if we move into the next operation, deletion operation is there. So what we can do with the help of this particular operation? So with the help of deletion operation, we can delete an element from the data structure. Okay, one single element we can remove from the data structure with the help of deletion operation. Next, a traversal operation is there. So traversal is nothing but processing each and every node in a data structure. So if you process each and every node in a data structure, then it is called as a traversal. So based on the data structure, whatever we are using, we can perform the traversal operation. So if I am using a linked list, then I can traverse the linked list in two directions: left to right traversal, right to left traversal. So I can process each and every element present in the linked list, either in left to right or right to left, and I can display the content and I can see the content. It's nothing but a traversal operation only. If I go with the stack data structure, even I can perform traversal operation on stack data structure and queue data structure also. So how I can traverse stack data structure means bottom to top I can traverse, or top to bottom also I can traverse. So likewise you can traverse queue data structure also, tree data structure and graph data structure also we can traverse it. Okay, so that is the meaning of traversal. Processing each and every node present in the data structure, okay, is nothing but traversal. Next, coming to the another operation, updating operation. So you created a data structure with some set of elements with some size. Now what you want to do is based on your requirement, you want to update some particular node value or some particular data present in the data structure, you want to update it. How you can update means with the help of updating operation you can update it. Okay, so updating is nothing but replacing old value with the new value. So based on your requirement, you are updating there in the data structure. Next one is searching operation. Okay, searching operation. So suppose you created a linked list with some 50 nodes. You want to search some particular element, whether it is present in the linked list or not. Okay, a particular data item is present in the linked list or not, you want to search it. Okay, how you can look for that particular element means with the help of searching operation only. Searching is nothing but it is used to find the location of a data item, whether it is present in the data structure or not. Okay, is nothing but searching. Now coming to the sorting, suppose the data items whatever you kept inside the data structure is not arranged in a right order. You want to arrange it in a right order. Okay, all the data items you want to arrange it in a right order. Then you can go with sorting operation. Okay, so there are number of sorting techniques are there based on our requirement. Okay, whatever the based on our requirement and our based on the performance, that execution time, these and all, by considering all these things. So whatever the sorting techniques is suitable for the data structure, we are going to pick any one sorting technique. So there are number of sorting techniques like bubble sort, selection sort, insertion sort, merge sort, quick sort, this and all there. So based on our requirement, we can select, we can pick any particular sorting technique and we will apply it on the data structure in order to arrange the elements in sorted order. Now coming to merging, next operation is merging operation. So merging is nothing but, in simple terms, merging is nothing but combining two items. Okay, combining two items. So here what we are combining means we are combining two data structures. Okay, so data structure 1 consists of some set of items, data structure 2 consists of some set of items. So what we want to do is we want to combine and we have to display it like a single data structure. Okay, then what we can do means we can go with the merging operation. So if you apply merging operation, you can combine two data structures and you can display it like a single data structure. In the sort order you can display it. Okay, next, destroy or delete operation. So this is the final operation, we will apply it on any kind of data structure. Okay, so if you look into the data structure operations from top to bottom, so it starts with the create operation and later it based on our requirement we can go with some certain set of operations. Once all these operations are over, finally what we have to do is we have to remove the data structure. How we can remove the data structure means with the help of either delete operation or destroy operation. That is the terminology we use. So what is the meaning of destroy or delete? Suppose if the data structure is no needed, that means after performing the operations, whatever the operations you executed, after that you don't want to use the data structure. Okay. In that case, what you are going to do means you will apply the destroy operation to that particular data structure. So what will happen if you apply destroy to that data structure means earlier whatever the memory occupied by the data structure, that memory will be released, and that memory you can use it for future purpose. That means your future related programs you can use it. So in order to avoid memory related issues, what we are going to do means after doing all the operations on the data structure, the final operation, destroy operation, we are going to perform it. Once if you destroy, that memory can be used for future purpose. So in C language, generally, we use a free function. Okay, free function which is available in the dynamic memory allocation concept. That function we use in order to release memory for the data structure. So these are all the basic operations that we can commonly apply it on any kind of data structures like primitive and non-primitive data structures based on our requirement. Now we will see representation of data structures. Okay. So till now we discussed about data structure and its a category. In that category, again we discussed about linear and non-linear, and what are all the operations that we can perform on the data structure that we discuss. Now what I want to do is I want to represent a data structure. Okay, stack I want to represent it in memory, or linked list I want to represent it in memory, queue I want to represent it in memory, trees, graphs, how I can represent all these data structures in memory. So this is the important thing. So any data structure in memory can be implemented in two ways. So one is using arrays, another one is using linked list. So first one, how we can represent a data structure in memory means using array representation, another one is linked list representation. These are the two possibilities. With the help of these two possibilities, I can represent any data structure in memory. Okay, so first one is also called as linear representation or sequential representation. Second one is also called as pointer based representation. Now, which one is efficient in terms of memory point of view? Which one is efficient generally? Okay, so when we are going to use the first approach and when we are going to use the second approach, now we will see. Coming to the first one, so array representation. Suppose you want to represent a particular data structure using array. With the help of that, what you can do means you can represent only limited number of elements. That means you can store only limited number of elements with the help of array representation. Suppose you want to store unlimited number of elements. That means you want to organize unlimited number of elements. Then you can go with linked list representation. So that is based on up to our requirement only. So if I want to store in a memory only limited number of elements, then I can go with array based approach. If I want to store unlimited number of elements, then I can go with linked list representation. So it's up to my requirement only, up to our requirement. Based on our requirement only, we can represent the data structure in memory. So that is a difference when we want to use array representation and when we want to go with the linked list representation. Now coming to the difference between array and linked list. Okay, array and linked list. So before going to the difference between array and linked list, if you look into the right side of the slide, there I given memory allocation process. Memory allocation process. See there, generally program generally consists of the following things like local variables, global variables, program instructions, and static variables. So, okay, so these are the items that are generally present in any program. Now, if you see that memory allocation process for these variables, local variables generally they get its memory from stack memory area. Okay, so there is a one memory area which is called as a stack memory area. So there that local variables it gets its memory. Now coming to global variables and program instructions and static variables, these three categories it gets its memory from a permanent storage area. Okay, permanent storage area. Now if you look into that particular memory map, there is a free memory area between local variables and global variable programming instructions and static variables. These two areas. If you look into stack memory area and permanent storage area, there is a free memory area between both of these two. That particular free memory area is called as heap memory area. So generally, if you are implementing any data structure using a linked list concept, So where it will get its memory means it gets its memory from heap memory area. Okay, so heap memory area, it plays a main role in order to performing any kind of implementation. You are going with a linked list based approach. That particular memory where it gets means it gets from heap memory area. Okay, so if you see dynamic memory allocation concept, okay, in that dynamic memory allocation, memory is allocated at runtime. Okay, so where this dynamic memory allocation functions, it gets its memory means it gets its memory from heap memory area only. Okay, so we know that dynamic memory allocation functions like malloc, calloc, realloc, and free functions, and its functionalities also we know that. Okay, these and all it gets its memory from a free memory area called heap memory area. Okay, okay. So now we will go to the difference between array approach and linked list approach. So what will happen if you are implementing a particular data structure using array? Or what will happen if you are implementing a particular data structure using linked list? Okay, if you see the differences, the first difference is the size of an array is fixed. Okay, so before using any array in your program, first what we have to do means we have to declare an array with its name and its size. So that size, whatever you specified in the square bracket of an array, that size is fixed. It cannot be modified. Okay, that is the first drawback of array. And coming to linked list approach, size of a linked list is not fixed. Why? Because that pointer based approach actually it uses dynamic memory allocation concept. Okay, so the memory where it gets means it gets that particular memory from heap memory area. It is a dynamic memory. Okay, so it's not constant. It keeps on changing. So this linked list based approach, it get it memory from heap memory area. The size is not fixed here. Okay, so that is the first difference between array and linked list. And coming to the second difference, memory is allocated from stack. Okay, so for an array where memory is allocated means memory it array generally it gets it from stack memory area. Coming to linked list gets its memory from heap memory area. Okay. Now coming to the third difference, it is necessary to specify the number of elements during the declaration. Okay, in case of array, if you want to use any array in a program means first you have to declare an array with its size. That means during the declaration itself you have to specify the number of elements in case of an array. Coming to linked list, it is not necessary to specify the number of elements during the declaration of an linked list. Okay, so here memory is allocated dynamically. Okay, memory is allocated during the runtime in case of linked list, whereas in case of array memory is allocated at compile time. So because of that reason, for an array we have to specify at the compile time itself. In case of linked list, the size is not required. Size when we are going to specify means at the time of execution time. Okay, now like if you see there I mentioned some more differences like insertion and deletion operations. Insertion and deletion operations, those are somehow difficult operations that we cannot perform on array. Even if we want to perform this insertion operation, deletion operation in an array, we need to shift the elements based on our requirement. Like where you are doing that particular insertion, that based on that position, you have to shift the elements. Likewise, if you are deleting a particular element from an array means based on removal of the element, you have to shift the elements. That means a proper shifting should be done in case of an array if you are doing insertion and deletion operations. So that insertion and deletion operations are somehow complex operations in case of array. Whereas coming to linked list, in linked list we can do this insertion and deletion operations in any position in the data structure. So you can insert an element at the beginning of the data structure or end of the data structure or user specified position also. You can do this insertion operation. As well as deletion also you can perform it. Any position you can do it. So these are all some differences between array and linked list. So based on our requirement, what way we want to represent the data structure in memory. Based on our requirement, we can go with any kind of category, array based approach or linked list based approach. But any data structure in memory is represented in both of these two forms. You can represent it like in array form as well as you can represent it in a linked list form. Okay, So if you are going with the linked list form means you have to use a concept called dynamic memory allocation. In case if you are writing your program in C language, you have to go with the dynamic memory allocation concept. So for that, what type of functions you have to use means you have to use malloc, calloc, realloc, and free functions you have to use. Okay, so that's all about that array versus linked list and the memory allocation process. Now we'll go with the next representation. So here in this slide, if you look into there, diagrammatically, I represented each and every data structure. Like array, how we can represent, queue, how we can represent, matrix, that means a 2D array. 2D array, how we can represent, tree, how we can represent, a graph, how we can represent, and hash map or hash, how we can represent. Next, stack, how we can represent, and linked list, how we can represent. All these things are a diagrammatical representation of all the data structures. In the further coming sessions related to this series, in case if further series is, I am going to explain clearly about all these data structures, how we need to represent this stack data structure, how we need to represent queue data structure, linked list like this, all these things I am going to explain in the further series. Now at this level in this slide, just I am going to cover what are all the terminologies that are related to each and every data structure. Okay, first we will go with the array. Okay, so array is nothing but it is a collection of homogeneous data items. Okay, so when we are going to use an array concept means if you want to store similar kind of data items, same type of data items, if you want to store, then what data structure you are going to use means array data structure you are going to use it. Okay, so if you see that top left side, so how I represented an array. In that array, I used all the integer data only. Okay, all the integer data. So all are same kind of data only. If I want to store same kind of data, then I can go with array representation. Okay. So again, arrays, there are multiple types of arrays are there, like a single dimensional array, multi-dimensional array. Okay. These are all multiple types of arrays. So if you see there, one example I mentioned like a matrix representation of array. Okay. It is also called as a 2D array, two-dimensional array or multi-dimensional array. So if you want to represent a matrix, so what type of array you can go with means you can go with a 2D array. 2D array or multi-dimensional array you can go it. Okay. So that is all about arrays. Now if you look into the stack, okay. So if you look into a slide, right side middle point, okay. So stack I represented. That representation is also how I done means array representation of stack. Okay. Array representation of stack only. So if you see that the terminologies, totally two terminologies are there, push and pop, and one pointer we are using called a top pointer. Okay, so stack, we know that a stack is a linear data structure. Okay, it is fall under the category of linear data structure in which insertions and deletions are performed only at one end called top of the stack. Okay, if you look into the stack diagram, there we inserted and we deleted an element from the stack by using a pointer called a top pointer. Okay, so with the help of the top pointer only, we can add an element into the stack or we can remove an element from the stack. Okay, so that is all about a stack. So stack is associated with two types of operations. One is a push operation, it's nothing but inserting an element into stack. Another one is called a pop operation, is nothing but to remove an element from the stack. So how we can perform these operations means here we are going to use one pointer called top pointer. With the help of that only, we can add an element into stack or we can remove an element from the stack. Now, what is the initial value of top? Okay, so generally if you refer any textbook, the different textbooks, they follow different kind of initial values for top. So if in some textbooks they use a top equal to 0, top equal to 0. And in some textbooks they mention like top equal to -1. So both of these two are correct only. So at the time of writing program, based on the initial value of a top, whatever the value we initialize, so we have to change our programming instructions in case of performing insertion and deletion operation. Okay, so top it can take 0, okay, or -1 also we can assign it. So at the time of writing program, that means a push operation or pop operation, we have to rearrange the program instructions. Based on that only, we can write our logic. Okay, that's all about a stack data structure. And next one, coming to queue data structure, If you see there in the topmost, I specified a Q representation. Okay, that is also array representation of Q only diagrammatically I mentioned there. Okay, so Q is associated with the two different pointers. One is a front pointer and a rear pointer. Okay, so Q data structure consists of two different pointers, front pointer and rear pointer. So with the help of rear pointer, we can add an element into stack. Sorry, with the help of rear pointer, we can add an element into Q. With the help of front pointer, we can remove an element from the Q. Okay, so if you recollect whatever I said for this stack, in case of stack, we use only one pointer, that is called as a top pointer. With the help of that only, we can perform push as well as a pop operation. Now, if you look into the Q data structure, in case of Q data structure, if you want to add an element, we use one pointer called rear pointer. If we want to remove an element, means we use one pointer called front pointer. That means in case of Q data structure, we use two different pointers. Okay, one for insertion, another for deletion. Okay, so here also I use array representation of Q and I stored same type of data items. Okay, so what a Q generally is called as, Q is also called as FIFO, first in, first out. That means whatever the element we added first into the Q, that is the element we remove first from the Q. Okay, if you look into the diagram, the front element, that one we added first into the Q. Next, remaining elements after that front pointer related element, remaining all are added in the next. So if you perform a removal operation, what will happen means the first element whatever we added, that element only removed from the Q first. So that's why it is also called as FIFO, first in, first out. But coming to the stack, stack is also called as LIFO, last in, first out. Okay, so in case of stack, whatever the element we add last, that is the element we remove first. That's why it is also called as last in, first out. Okay, so now if you look into the another diagram, a linker list mentioned. Okay, so bottom, if you look into the PPT, bottom position I mentioned a linker list. So starting one blue color, one node is there. That is called a head node or start node. And the next further nodes are there. Totally 6 nodes I mentioned there. And each node is connecting with two different arrows. One is a forwarding arrow, another one is a reversal arrow. Forward, backward arrows are there. So that means here this diagram represents a double linker list. Double linker list. Now coming to the general definition of a linker list is a collection of nodes. It is a collection of nodes and all the nodes are linked together in some sequential manner. Okay, all the nodes are connected together in some sequential manner. It's nothing but a linker list. So here in this particular PPT, I mentioned a double linker list. Okay, two links are there, one node to another node, two links are there. That's why it is a double linker list. Okay, so here the general definition what I given is, I given general definition related to a linker list. Linker list is a collection of nodes and all the nodes are linked together in some sequential manner. Okay, so in a linker list, there are variants of linker list are there, like a single linker list, double linker list, circular single linker list, and circular double linker list. These are all different variants of linker list. Okay, so linker list consists of set of nodes, and that linker list actually front one start node or head node is there. That start node or head node, it holds the address of the first node, and the last node next field of the linker list is assigned with null pointer. Okay, null value. Okay, so here also integer data items only I stored, but that representation is a pointer based representation. Okay, now if you look into the tree, okay, so top left side, top below, if you look into the below of array, I mentioned a tree. Okay, so tree is a nonlinear data structure and it is a collection of nodes in which all the nodes are arranged in hierarchical fashion. If you look into there, all the items are arranged in level by level. That is nothing but a tree data structure. Okay, so in a tree, topmost node is called as a root node. Remaining all are called as children of the root node. Okay, so that is a tree kind of structure. In coming series, at the time of discussing a tree kind of concepts, there I am going to give you a clear idea about what is a tree, this and all. I will give you a clear idea. Okay, so that is a tree representation. So it consists of only one root node. the topmost node, which is called as a root node. Remaining are like act like a childrens of the root node. Again, if you look into the childrens, again those childrens also consists of one root node and childrens, like that. It's there. Okay, so that is a tree kind of representation. Now coming to the graph. Okay, so if you look into the right side of matrix, uh, graph is there. Graph is nothing but it's a pair of vertices and edges. It's nothing but a graph. If you look into that particular diagram, okay, so the diagram consists of vertices. So vertices are represented in circle fashion. Edges are represented like a link or line fashion. Okay, so graph is nothing but it's a pair of vertices and edges. Okay, and next, if you look into the right side of the PPT, there are some more trees I mentioned. Okay, and hashing also I mentioned, hash tables. Okay, so these are all different kinds of data structure. Here, especially this particular PPT, what it is showing to us means how diagrammatically we can represent any data structure. That and all I mentioned here in this particular PPT. So majority of the things I mentioned like in array-based representation only. In the coming sessions, we are going to see about how we can represent a stack or a queue in a linked list fashion. These and all we will see in the coming sessions. Now, coming to the references to prepare this particular PPT or to prepare this particular content, what are all the textbooks I referred? So here, whatever the textbooks I mentioned, these are all somehow standard textbooks. So these are all the textbooks I followed. So fundamentals of data structures in C, like Ellis Horowitz and Sartat Sahani. It's a very good standard textbook which will cover all the concepts related to data structure. Like that, second, third, fourth references also like textbooks I used for presenting this particular PPT. And thank you for attending this presentation.